We're going to go through the content of chapter 4, where we're going to talk about repetition structures, also known as loops. So here's what we're going to talk about in this video. There's two kinds of loops that we're going to talk about: while loops, which are known as condition-controlled loops, and for loops, which are count-controlled loops. The difference between these are really how many times do you know if you're going to want to do the loop. So we'll talk about those as we go through that. Then there's some steps to things you can do inside a loop if you're unsure how many times the loop's going to run, and then also sentinel values, which is a special case that we use to end a loop when we're processing input from the user or from some external source. We'll do nested loops briefly, and then we'll look at Java, and then in subsequent videos we'll have some exercises. So here's repetition. These are called loops, typically in our vernacular of programming. It basically allows you to write a block of code and then execute that block of code multiple times with input that's being modified or changed each time the iteration runs. So this helps you if you want to say you want to calculate an average of numbers, right? So you want to input numbers and then add them up and calculate them. You need a loop to do that because you're going to want to do the same thing more than one time. You don't want to. This also helps you to avoid writing duplicate code, because if you want to do something 3 times, you don't want to just write the code once and then duplicate it two other times for a total of 3. You really want to be able to reuse that code multiple times. So there's two types of condition-controlled loops. These are basically loops that you have when you're not sure how many times you're going to want to do something. You're going to want to run this loop until something happens that makes your desire to end true. So there's a while loop and a do while loop. The difference here is really the pre-test and a post-test, which we'll see in a second. Some languages also have a do until loop, which is really nearly functionally equivalent to the do while loop. We're not going to talk about those here. Those are not common in Java, and so we're not going to really use them. Most of what we're going to do is the while loop. In my experience, I almost always use the while loop. I hardly ever use this do while. That's not that the do while is not functional. It's just in my experience, the while loop or a for loop pretty much gets you everything you need. Here's how it looks in some pseudocode and in a flowchart. So the while loop is a pretest loop. That means that you define a while loop with a Boolean expression, a Boolean condition, and the statements inside the while loop run until this condition is true. So as long as this condition is true, then the statements run. So this loop will execute 0 or n times. So it could execute 0 times if the condition is false when the first time the loop begins, in which case these statements won't run. If this condition is true, then these statements will execute. It's important, very important, to make sure that one of these statements does something that will change the condition. Otherwise, you'll wind up with an infinite loop that will never stop. Here's what it looks like in flowchart. You see we're using the condition structure, but instead of having our flow out of our statements and our block fall down, it goes back up prior to the condition. So this is an indication of a loop with a condition that causes the exit. Here's an example of one in pseudocode. Declare an integer while the count is less than 10, do something with the count, and then increase the count. This is what I'm talking about. It's really important that something in the while loop will do something to change the condition so that it will eventually, the condition will eventually be false and the loop will end. This is the do while. This is a post test. This means that in this case, the statements, here's the pseudocode for that, and here's the flowchart. In this case, you're guaranteed that the block will run at least one time. In this case, we run the statements and then the condition is at the end. So you get one execution of the statements, you test the condition, and then you go back. Whereas in a while loop, the testing of the condition happens before the statements run. So you can see that they're really very similar. And a while loop will typically get you all the execution and the process you need. So, but you will see these are not uncommon. But in my experience, I don't use them very much. This is what it looks like in flowchart. You can see that the statements come first and then the condition, and then we loop back. So this is basically the same as looks very similar to the while loop, except the statements execute first, and then the true condition, the true exit from the while loop goes back before the statements. Here's what it looks like in pseudocode. Here we have a count controlled loop. This is what's known as a for loop. You typically use a while loop when you don't know how many times you want to do something. Do this until something happens, and I don't know how long it's going to take for that thing to happen. A count controlled loop, a for loop, is when you generally know how many times you're going to want to do something. I'm going to want to do this once for every item in this list, and I know how big the list is. I'm going to want to do this 5 times. I'm going to want to do this X number of times. If you know how many times you're going to want to do something, you're typically going to use a for loop. If you don't know how many times you're going to do something, you'll use a while loop. So a for loop is typically used as a counter and a condition and an incrementer. And so you define that with three steps when you create the for loop: initialization, the test or the condition, and then the incrementer. So we'll see that here. The for loop looks a lot like a while loop in the flowchart. You can see that we have some kind of initialization that happens here. Then we have the test, the condition. We do the statements, and then we run back, in the execution prior to the test. So this looks very much like the while loop. The only difference that we have between the for loop and the while loop is that we added an initialization step to a counter. So these are called a for loop. In pseudocode, it's going to look like this: for I equals 1 to 10, something like that, and then statements in the middle. And this will typically run. The assumption in pseudocode is that the counter variable is automatically incremented at the end. You generally don't have to include that in the pseudocode unless you want to. It's built in Java and most languages. The incremental step of the for loop is built into the definition of the for loop. Here's what it looks like in pseudocode with actual code. We see we have the max value here. We've declared it as a constant. 1 to 5, display hello world. So in this case, the counter this block, display hello world, will execute 5 times. The counter will be 1, 2, 3, 4, 5. So it'll have a counter value of 1, display hello world, counter value of 2, display, etc., until the counter is equal to 5. When counter this is then executed or incremented to 6 and the condition is evaluated, then that condition is no longer true, and so the for loop ends. Here's another example in flowchart of what we just saw, of the pseudocode we just saw. You see that we come in, we execute the initialization, we do the test, we go around this loop 5 times, and then we fall out the bottom. It's you can use the what's called the elongated hexagon to save some coding on a for loop. This could look like a while loop. This could just as easily be a while loop. If you see the way that we've coded this using the decision symbols. But if you want to save some coding, you can use this elongated hexagon value, where basically this encapsulates the for loop all in one symbol. So it saves you a little time. You don't need the initialization. You don't need the test. You just do the encapsulation and then write your loop here. Here's another example of that. You can see this one. This is a lot easier. It requires fewer symbols when you're doing a flowchart to use the elongated hexagon for a for loop. When you do a while loop or a condition controlled loop, you still need to use the decision symbols. For loops allow you to also increment or decrement. So the incrementing value, you're going to count by 1. That's generally what happens. You're going to count 1, 2, 3, 4, 5 by 1. Sometimes you want to count backwards, count from 10 to 0. Sometimes you might want to count by 2s. Maybe you only want to do even interactions. You can count however you want, up and down, as long as your condition will eventually be false once the incrementer completes. Always remember, you've got to make sure that if you're writing a loop, you got to make something that happens inside the loop is going to cause the condition to be false at some point for the loop to end. So so keep that in mind. Like I said, a for loop, that's built in, but for a while loop, you always need to make sure that something in the loop is going to happen that will eventually change the condition so that the loop will stop. Okay, this is something we do in loop often, is that we're counting numbers, or we're going through a list of numbers. Either the user is entering numbers or maybe I'm reading them from a file or something like that. And so I want to count them or summarize them in some way, so I can use this running total logic. So you see here, I'm coming in, I've made some declarations. I have a for loop here, and inside the for loop, I'm asking for the user to enter a number. I'm then inputting the number. Then maybe I do a little processing with that number. Maybe I print it out. Maybe I do maybe I do some calculation on it or something to give some output to the user. But then I do this running total. So this box we see here is a running total. So once I exit the loop, in this case I'm doing a five iteration for loop. I'm going to enter 5 numbers. Total at the end of my 5 iterations is going to be the sum of all those numbers. So it's also important to note that I've declared the number. It's declared up here prior to the loop. In Java, if you declare a variable inside the loop, then that variable does not exist outside the loop. And so if you're going to do a summation or running total, you need to make sure that you have scoped this variable in the main procedure and not inside the loop. Otherwise, when the loop ends, this variable won't exist and your summations will be gone. So this is a running total, which we're going to do an example of this in just a minute. A sentinel value is also a special way that can help you get out of a loop. So maybe you're doing a for loop and you're taking input from the user and you don't know when the user wants to end. So you can define the sentinel value. So maybe you're asking for a list of integers that are all positive, and so you can have a negative number be the sentinel that will cause the loop to end. So typically you want to the sentinel value is going to be some kind of input, either from the list or from the user, that is outside the context or the domain of your valid input. So maybe it's going to be, maybe you declare it's a list of string values, and maybe you declare that the word quit is not a valid input. It's not going to be valid in the context of your problem, and so it can be the sentinel value to cause the loop to end. Sometimes if there's no obvious exception to your context of your list, then you typically have to pause and ask a second question: do you want to continue? And then you can run. So your input will actually be 2 steps: inputting the contextual value, and then a second question to say, do you have any more values to enter? And then you can quit. So we'll see some examples of both in this, but that process is called the sentinel value, processing a loop, looking at input, and then having a special input value indicating that the loop should end. You can also put loops inside of loops, and so here's an example of one. So you think of a clock. This is a day, so there are 24 hours in a day. We're counting from 0 to 23. Inside each hour, there's minutes. Inside each minute, there's a second, and then we can display this. So in this case, this would actually display every second of every day. So this loop would run 60 times. Each time this loop runs 60 times, this loop runs 24 times. So this loop, for every one loop this runs, for every one loop on this outer loop, it runs 24 times. For every iteration, this one runs 60 times. For every iteration of this one runs 60 times. So for every, so you get 24 times 60 times 60. You're going to get 86,400 iterations of this example. So you could actually code this if you wanted to do a little fun test and see how this works. But essentially, this code will display a clock output for every second of an entire 24-hour period. 86,400 being the number of seconds in a day. All right, let's look at how we code loops in Java specifically. So we're going to add we're going to learn about some special numeric operators. We have the incrementer and the decrementer. This is num++. This just simply means add 1 to the variable num. So, and you have the similar one, which is the decrementer. So you'll see this in the for loops. You'll see this when you're counting or doing running totals. You'll often see these types of incrementers. Just simple shorthand notation to say add 1 to the value of num. So if num is 2 and I do num++, once the statement runs, num is now 3, and it works the same as a decrementer. Here's what a for loop, or a while loop rather, looks like in Java. Use the keyword while, all lowercase. You have a Boolean expression, just like a decision, enclosed in parentheses, and then you open your block using the curly braces, and then you have statements in the middle. Okay? Remember, something in the statement needs to change this expression so it will eventually be false. The while loop runs as long as the Boolean expression evaluates to true, then the statements will run. Once the statement ends, we come back, we check the expression again, and we continue to execute. Here's one that's printed. This one is actually could just as easily be written as a for loop. But here we have count is 0. While count is less than 5, then let's do this. Let's do this block. So we print this out. Count, then we use the incrementer count plus plus. So this loop will run 5 times. Here's the do loop. The do loop works very similar to the while loop, except you're guaranteed one iteration of the block. In this case, the do declares the loop. We open the loop using a block. We have our statements, but the expression is at the end. So this runs as long as you get one execution, and then you test the Boolean expression. If the expression is true, you get a second execution. If the expression is true, you get a third execution, and so forth. So here's what it looks like in the same example before. Just know that you're guaranteed at least one execution in the do. That's really the primary difference. It's a post-test loop as opposed to a pre-test loop using just the while. Here's a for loop. A for loop has a unique definition in that we use the keyword for, and then we put 3 expressions inside parentheses here. So you have the 3 expressions initializing your counter variable. This is typically a definition of a variable and setting it to an initial value. You then have your Boolean expression. This is a test. This is, we'll continue the loop as long as this expression is true. And then you have the incrementer, which happens at the end. And then your statements in the middle. Okay. It is worth noting that this expression is a pretest. So it's possible that your for loop won't ever run, depending on how that code is initialized. Here's what it looks like. For count equals 1, count is a variable here. It must be declared. So either you can declare it here on this for loop, or you can declare it before. Either way, if you declare it as part of the definition of the for loop, then that variable count only exists for the for loop, and it does not exist before or after the for loop is executing. So this is the definition and the initialization of count. Here's my expression: do this for loop as long as count is less than or equal to 5, and at the end of every iteration, increment count by 1. Okay, so we'll see this will execute with count equals 1, 2, 3, 4, and 5. When count equals 6, we're going to stop because we're using the less than or equal to 5. It's very important. Often you'll want to start at 0. So in most of the data structures in Java, they are numbered with the first element in those data structures being numbered as 0. Java is a 0-based counting language, so we're going to start at 0, 1, 2, 3, 4. So it's important to note that we'll often start a loop at 0, and so if you want to execute that 5 times, it's going to be start at 0 and go to less than 5. In this case, we're doing 1 to less than or equal to 5, but if you start at 0 and go less than 5, then you still get the same 5 iterations. So just be clear here that wherever you're starting, sometimes you'll start at 0, sometimes you'll start at 1. You want to make sure that you're using the less than or equal appropriately so that you get the correct number of executions. Okay, we'll do these examples in a subsequent video.